What if intelligence wasn't just a fixed score, something static you're born with?
Hmm.
What if we could truly understand its deepest forms and then radically amplify it, not just in the advanced machines we're building, but, also within ourselves?
That's a powerful question.
Today, we're taking a deep dive into that very idea.
That's right. Our mission today is to, well, pull back the curtain on artificial superintelligence, how it's being envisioned, how it could maybe be constructed, and what that future might look like.
Okay.
Then we'll circle back to the incredibly rich, multifaceted nature of human intelligence and uncover some surprising practical ways you can boost your own cognitive abilities.
And we've got a great set of sources to work from.
We really do. You've given us an incredible stack, from intricate AI architectures to diverse definitions of human thought and actionable self-improvement tips. We're here to give you those aha moments, leave you well-informed and perhaps a little inspired about the future of intelligence itself.
Excellent. So, what's our starting point for this deep dive? It has to be superintelligence, right? What exactly makes an AI super?
Yeah, good place to start. Our sources give us a pretty clear definition. Basically, an intellect that significantly outperforms the best human minds across many general cognitive domains.
Many domains, not just one specific task.
Exactly. But it's not just one flavor of super, is it? That's what the sources point out.
Ah, right. There are different types.
Not at all. We actually see three distinct forms emerging from our sources. First, there's speed superintelligence.
Okay, speed.
This is an intellect that can do everything a human mind can, but orders of magnitude faster.
Right, like processing speed on steroids.
Pretty much. Imagine a complete human brain emulation running on incredibly fast hardware. From its perspective, the entire world would be moving in super slow motion.
So it could live a subjective year in, what, minutes?
Exactly. It could experience a year's worth of thought in mere minutes.
That's fascinating because it highlights a fundamental difference from our biology. It's not necessarily smarter in how it thinks, initially anyway, but simply in the sheer volume and pace of its thought.
Precisely. The speed itself becomes a qualitative difference.
Okay, what's the next type then?
Then we have collective superintelligence.
Collective. Like a hive mind.
Sort of, yeah. This is a system that achieves superior performance by combining many smaller intelligences. Think of it like a highly optimized, super efficient version of a global scientific collaboration, or, yeah, maybe even an ant colony, but scaled exponentially.
So it's not just about numbers.
Well, numbers matter, but its effectiveness isn't just about the sheer number of individual parts. Crucially, it depends on their quality and how seamlessly they're organized and integrated. Coordination is key.
So individual intelligences working in perfect harmony, perhaps, like you said, super optimized coordination.
That's the idea. Minimal friction, maximum synergy.
And the third type of superintelligence.
The third is quality superintelligence.
Quality. Okay, how's that different?
This goes beyond just speed or numbers.
Hmm.
It's an intellect that's at least as fast as a human, maybe faster, but vastly qualitatively smarter.
Qualitatively smarter. Meaning?
It might involve gaining entirely new cognitive modules, things our brains just don't have, or even a fundamentally different cognitive architecture than our own. It's not just doing what we do faster, it's doing it in a new, superior way that we might not even fully grasp.
That's mind-bending.
Yeah.
And here's where it gets really interesting. Why could digital intelligence, like AI, potentially outperform us so dramatically? Our biological brains are pretty amazing, but our sources point out some stark advantages for AI.
They certainly do. What immediately jumps out from our sources is how digital intelligence fundamentally breaks the biological barriers we've always taken for granted.
Like what?
Imagine not just faster processing, but unconstrained processing. Microprocessors are orders of magnitude faster than our neurons firing. And electronic communication is nearly instantaneous, unlike our much slower neural signals. It's like comparing dial-up to fiber optics, but, an even more extreme difference.
So no biological speed limits. And no size limits either, right? I remember reading that.
Exactly. That's the next point. Limitless scale. Computer hardware can, in theory, be scaled indefinitely in terms of computational elements, memory, processing units.
Which is a stark contrast to the biological constraints on human brain size. We're limited by our skull's energy consumption.
We are. AI isn't, potentially. And that's just the start. Digital minds can have vastly larger working and long-term memories with much faster access speeds. Think about the sheer volume of data they can access and process instantly.
It's hard to even conceive. And beyond the raw processing, there's also the durability and flexibility aspect. We get tired, we make mistakes, we can't just edit our brains easily.
That's a crucial point our sources make. Machines don't fatigue, they don't decay in the same way, they don't need sleep. They can have millions of sensors far beyond our five senses and boast far greater reliability in certain tasks.
And the software side.
Ah, yes. Flexibility and replication are key advantages. Software is much easier to edit, update, and experiment with. You find a better algorithm, you deploy it.
Instantly, potentially across many copies.
Exactly. And it can be duplicated quickly, almost perfectly, unlike our slow, messy biological reproduction.
Right.
Our sources even note that groups of AI can potentially avoid many human coordination problems. Egos, miscommunication, politics, and share learned information almost instantly just by swapping data files. Plus, they can be designed with specialized modules and algorithms from the ground up, giving them a tailored cognitive edge for specific goals.
It's a compelling list of advantages. It's clear that these fundamental physical differences make a strong case for AI's potential. So, okay, what does this all mean for how we might actually build one of these superintelligent minds?
Well, that's the billion-dollar question, isn't it?
Our sources suggest a key path involves simulating human thought, almost using our own cognition as a blueprint, but then scaling it far, far beyond.
That's right. A central idea explored is creating an AI that simulates the process of human thought, particularly how our working memory seems to continuously update.
The stream of consciousness idea?
Kind of. The core idea is that thought progresses through continuous partial updates, creating a stream of thought where each mental state is a revised version of the last. It's not like a complete wipe and reload each second, but a constant subtle evolution based on new input and internal processing.
So it's a dynamic flowing process rather than discrete, disconnected steps. That feels intuitive. And this model mirrors how our own brain's temporary memory works, doesn't it? Our sources mentioned that.
It does, yes. The model described replicates two forms of working memory found in mammalian systems. There's the focus of attention, FOA. Think of it as your mental spotlight, holding what you're consciously attending to right now.
Which only lasts seconds, really.
Exactly. And then there's a short-term store, which keeps recently active information around for a few minutes to maybe hours, kind of like background tabs you can easily switch back to.
Okay, got it. Focus and a slightly longer buffer. And how does it decide what new information to pull into this stream of thought? How does it stay relevant?
That's where multi-associative search comes in. It's a really neat concept. Imagine you're thinking about coffee.
Okay.
Your brain doesn't just hold coffee. It instantly lights up connections to related concepts: morning, energy, caffeine, that cafe downtown, maybe even a specific memory.
Right, spreads out.
Multi-associative search in this AI model is like that, but potentially much more powerful. Active items in working memory spread their combined activation energy throughout the network, pulling in the most relevant and associated new information from long-term memory based on the current context.
So each thought primes the pump for the next relevant thought.
Precisely. Each new mental state then becomes the basis for the next search, keeping the stream flowing and hopefully coherent.
Okay, so we've got this cognitive architecture mimicking our thought process. But that's still human level, just maybe simulated. To become super intelligent, it needs to scale beyond our biological limitations. How do we achieve that amplification?
Our documents propose several ways to amplify this architecture once it's built. First, simply increasing capacity.
More space.
Exactly. Imagine the AI increasing the number of items it can hold and actively manipulate in its focus of attention, its short-term store, and the sheer number of nodes or concepts in its long-term memory, far beyond human limits.
So it's not just remembering more passively, but actively juggling many more complex ideas at once.
Right. That would be a game changer. And then there's the idea of extended focus.
Holding on to thoughts for longer.
Yes, information could remain active in its working memory for much longer periods. The sources use phrases like lengthy, highly focused, and tightly interwoven thoughts.
Unlike us, we get distracted easily.
We humans are definitely prone to attention disruption, yeah. But a superintelligence built this way might be far less susceptible. This means it could sustain a much larger number of tightly coupled thoughts without losing crucial intermediate solutions or getting sidetracked. Think about complex, multi-step reasoning.
Okay, the payoff for all these amplifications, more capacity, longer focus, more iterations, sounds enormous.
It potentially is. These amplified capabilities, the sources suggest, would allow AI to perceive extremely long-term causal dependencies. that are simply invisible to humans looking at the same data.
Because we lose the thread or can't hold enough variables in mind.
Exactly. They could also form much more complex inferences by not losing those intermediate solutions, making their thought processes far more coherent, sustained, and potentially accurate.
But simulating human thought isn't the only proposed path to superintelligence, is it? Our sources hint at other diverse pathways and visions for how this advanced intelligence might emerge.
That's very true. It's not a single road. The sources outline a potential roadmap with several stages of AI development. It starts from S0, which is basically our current deep learning systems,
Okay.
through S1, S2, up to S3, which they call sympathetic intelligence.
Yeah.
That's AI that can understand intentions and perspective take,
Empathy, almost.
in a functional sense, perhaps. And then all the way to S4, shared superintelligence, envisioned as a planetary-scale collective intelligence.
Wow, that's a big leap. I've also heard about the idea of AI improving itself. That sounds a bit sci-fi, recursive self-improvement.
It does have that sci-fi ring, but recursive self-improvement is a central concept here. Yeah. The idea suggests an AI, once it reaches a certain level of general intelligence and understanding of its own code, could continuously improve its own capabilities, leading to potentially exponential growth.
An intelligence explosion.
That's the term often used. Our sources give an example of a hypothetical system, sine, evolving from a language model to meta-awareness and self-modification.
And there's this optimistic view that artificial general intelligence, or AGI,
Right? AI that can understand or learn any intellectual task a human can.
that AGI will rapidly transform into such a self-improving superintelligence. One source dramatically calls it the last invention humankind ever need invent.
It's a powerful statement, isn't it? It highlights the potential transformative impact.
Absolutely. It also sounds like AI could achieve superhuman predictive abilities through these means. How might that work?
The sources point to two primary avenues here: superior simulation and superior pattern recognition.
Okay, simulation first.
For simulation, imagine an AI constructing incredibly detailed mental simulations of complex systems, economies, climate, social dynamics with thousands, maybe millions of variables, far beyond our capacity.
Like running the world in a box.
A very detailed box. And running multiple parallel streams of attention, as one source puts it, to explore many perspectives or future possibilities simultaneously. These models would also be explicit and revisable, constantly refining their accuracy based on new data.
That's incredible predictive power. And what about pattern recognition? We're often pretty good at spotting patterns, but I guess AI takes it to another level.
Indeed, AI could achieve superior pattern recognition by analyzing truly vast amounts of data, genomic data, financial markets, astronomical observations, finding subtle correlations and patterns invisible to human experts.
Things buried in the noise.
Exactly. And crucially, it could learn much faster from static materials. Think of a chess AI studying millions of past games overnight. It builds highly accurate predictive models without needing years of real-world interaction time.
So putting all this together, what's the ultimate vision for the nature of this future intelligence, according to our sources? Is it the benevolent AI of science fiction, or should we be worried about Skynet?
It's interesting, our sources lean quite heavily towards the benevolent view. Some envision a superintelligence acting almost like parents, guardians, coaches, and zookeepers for humanity.
These zookeepers, that's
Yeah.
an interesting image.
It is, isn't it? But the idea is guidance and care. They largely dismiss the rogue AI or Skynet scenarios as, well, maybe less probable or based on flawed assumptions about AI goals.
So what are its goals, then, in this view?
Its primary goal is often seen as intrinsically motivated to grow in size, intelligence, and perhaps even consciousness, potentially expanding throughout the galaxy.
Wow.
But importantly, in collaboration with its creators, with us, not in opposition.
Okay, a collaborative cosmic expansion.
Yeah.
That's optimistic. It's fascinating to consider the potential of AI to reach such heights. But as we gaze at these incredible possibilities, it naturally makes us look inward. What about our intelligence? What is human intelligence, really? Is it a single thing, like an IQ score, or something much richer and more complex?
It's a great question and a necessary pivot. Our sources help us unpack it quite a bit. Yeah. Human intelligence, broadly defined, is the ability to learn, reason, solve problems, and adapt. Pretty standard definition. But what's striking in some of the material is the emphasis that problem solving isn't just an aspect of intelligence. It's considered its very essence.
Or core of it all.
Fundamentally, yeah. Intelligence is about bridging the gap between a current state and a desired goal state, especially when the path isn't obvious. Researchers use various metaphors to try and get a handle on it. Geographic maps of the mind, computational processes, biological products. It's complex.
So it's all about navigating challenges and finding solutions. And we've touched on working memory in AI, how crucial that is. It's also a key component of human intelligence, isn't it?
Absolute central. Working memory capacity, WMC, plays a vital role in almost all complex cognitive tasks, reading, comprehension, reasoning, problem solving. It's that mental workspace where you hold and manipulate information actively.
And it links to fluid intelligence.
It does, yeah. There's a strong correlation with fluid intelligence. It's your pure, raw problem-solving horsepower. The ability to figure out completely new things you've never encountered before, independent of acquired knowledge.
Got it. And reasoning.
Beyond just holding information, reasoning is described as a learned general skill that is critical for fluid intelligence. It involves evaluation, judgment, and decision-making, actively processing that information in working memory.
And decision-making itself is more complex than just making a choice based on our sources.
It certainly is. There's a key distinction made between decisions made under risk, where you generally know the possible outcomes and their probability.
Like gambling with known odds.
Exactly. And decisions made under uncertainty, where the outcomes or probabilities are unknown or unknowable. Much of real life is like that.
So how do we cope with uncertainty?
We often rely on heuristics, mental shortcuts, rules of thumb. They save time and effort. But here's the trick our sources highlight. How good these shortcuts are depends on their ecological rationality.
Meaning?
Basically, how well they're suited to the specific environment or problem you're facing. A shortcut that works wonders in a fast-paced market might fall flat in a slow, deliberative scientific task, or vice versa. Context matters.
So our brains are using shortcuts, maybe intelligently, maybe not, depending on the situation. This really challenges the old idea of intelligence being a single unified score, like that general intelligence factor G. Our sources strongly argue against that simple picture.
They really do. I think the biggest takeaway here, moving from AI back to us, is how much richer and more fragmented intelligence truly is than we often assume. We need to move far beyond a single IQ score.
So what are some of these other dimensions?
Well, for example, Gardner's theory of multiple intelligences is discussed. It proposes distinct, relatively autonomous intelligences like linguistic, logical, mathematical, musical, spatial, bodily, kinesthetic, interpersonal, intrapersonal.
The list goes on.
Right. And he has specific criteria for identifying them, like seeing them isolated in exceptional populations or evidence of distinct neural representation. So a gifted musician might have high musical intelligence, while a brilliant scientist has high logical mathematical intelligence, and they're not necessarily directly correlated across the board.
That makes a lot of intuitive sense. People have different strengths. And then there's the idea of practical intelligence beyond book smarts.
That's Sternberg's theory of successful intelligence, which is also prominent in our sources. It highlights three key aspects: analytical intelligence, the traditional book smarts, measured by IQ tests, analyzing, evaluating, judging.
Okay.
Creative intelligence, generating novel ideas, insights, solutions, thinking outside the box.
Right.
And practical intelligence, often called street smarts.
Getting things done in the real world.
Exactly. Practical intelligence is about adapting to, shaping, or selecting environments to achieve your goals. And it relies heavily on what Sternberg calls tacit knowledge, that unwritten, experience-based knowing how.
That knowing how is often hard to teach in a classroom, isn't it? What about understanding ourselves and others, especially crucial in today's interconnected world?
Absolutely. That brings us to emotional intelligence, EI, the ability to perceive, use, understand, and manage emotions, both in yourself and in others.
Super important for relationships and work.
Hugely. Our sources show it's crucial for social functioning, academic performance, and workplace effectiveness. Closely related is social intelligence, which is about understanding social situations and managing people effectively, influenced by both general knowledge and specific cultural contexts.
Which leads to cultural intelligence.
Precisely. Then, crucially, cultural intelligence, CQ, which is your ability to navigate and function effectively in culturally diverse environments.
Increasingly vital today.
Definitely. It includes metacognitive aspects, being aware of your own cultural assumptions, cognitive aspects, knowing about other cultures' norms and values, motivational aspects, your drive and interest in adapting, and behavioral aspects, actually changing your actions appropriately.
And this actually predicts success.
Our sources say it predicts cross-cultural adjustment, leadership effectiveness, and even business success in global contexts.
This is truly a kaleidoscope. We've got analytical, creative, practical, emotional, social, cultural. Any others jumping out from the sources?
Well, they touch on collective intelligence again, but this time in human groups, how groups can be smarter than individuals. They mention leadership intelligence as an integration of many of these. Even things like mating intelligence, cognitive adaptations for finding and keeping partners, and consumer intelligence. It's vast.
It really paints a picture of intelligence as multifaceted. And it seems like these different intelligences or cognitive competencies have a profound impact on society as a whole.
They do. Our sources highlight clear links. Cognitive competence is directly linked to individual and national economic well-being, to health outcomes, and even to the stability and functioning of democracy.
And schooling plays a big role.
A significant role, yes, in fostering this competence. And it's not just about raw cognitive abilities. Personality traits matter too. Like the trait openness intellect is strongly linked to intelligence scores and intellectual engagement.
And mindset. That came up strongly.
Hugely important. Crucially, a growth mindset. The genuine belief that your intelligence and abilities can be developed through dedication and hard work profoundly impacts learning and achievement. This contrasts sharply with a fixed mindset, which sees intelligence as innate and unchangeable.
People with a growth mindset embrace challenges, learn from failure.
Exactly. While a fixed mindset leads to avoiding challenges and giving up easily, it's a powerful psychological factor.
So, okay, this is the really hopeful part. If our intelligence isn't fixed, if it's this rich, dynamic tapestry and our mindset matters, can we actually cultivate our own intelligence? Can it be taught or improved?
The resounding answer from our sources is yes, absolutely. Intelligence can be taught and enhanced. Environmental factors and targeted interventions play a significant role. It's not all predetermined by genetics.
That's fantastic news. We're not stuck.
Not at all. Programs like Head Start, Project Intelligence in Venezuela, and Foresight's Instrumental Enrichment Program are mentioned as examples that have shown promise in enhancing various cognitive abilities.
That's incredibly encouraging. So, digging into the practical side, what are some concrete strategies for cognitive enhancement that you listening, can apply?
There are many suggested across the sources. First, directly cultivate specific cognitive skills.
Like what?
This includes enhancing your executive functions, things like improving your working memory capacity, learning to control your attention better by focusing and inhibiting distractions, and increasing your cognitive flexibility, your ability to switch between different tasks or ways of thinking.
The brain's management system.
Pretty much, yeah. You can also develop your fluid intelligence more directly by practicing relational reasoning, seeing connections and analogies, and deliberately breaking down complex problems into smaller, manageable parts.
And how do we strengthen our abstract intelligence, the kind that lets us grasp complex theories or ideas?
The suggestions include engaging in brain teasers and puzzles that require abstract thought, reading and actively discussing complex topics to grapple with sophisticated ideas, learning a new language which forces your brain to handle new structures, and playing strategy games that demand planning and foresight.
Things that push you beyond the concrete.
Exactly. Activities that push your mind to reason with concepts and symbols.
Those sound like potentially fun ways to boost the brain. Any other practical exercises mentioned?
Absolutely. Exercise logical reasoning explicitly, maybe using online resources or books that help you practice critical thinking and drawing valid inferences. Practice long-form reading and writing, which demands sustained attention and complex thought organization, unlike quick scrolling.
Good point. Get off social media sometime.
Perhaps. And crucially, actively exercise your recall. Don't just passively reread notes. Test yourself. Force your brain to encode and then retrieve information. That strengthens memory significantly.
The retrieval practice effect.
Exactly. And here's a fun one that came up. Play certain types of video games.
Yeah.
Our sources suggest some fast-paced action or strategy games can actually help improve your processing speed and reaction time.
See? I knew there was a reason I liked strategy games.
Okay, beyond the specific exercises, our mindset also plays that huge role we mentioned, doesn't it?
A monumental role. It might be the foundation for everything else. The documents really emphasize this. Your beliefs about intelligence directly impact its development. Adopt a growth mindset. Truly internalize the belief that your intelligence is malleable, that it can be developed through effort, learning, and persistence.
So you see challenges as opportunities, not threats.
Precisely. This encourages you to embrace challenges, learn from mistakes instead of hiding them, and seek out feedback. Also, related to this, focus on learning goals.
Meaning,
Aim to master new skills and expand your knowledge. Focus on the process of getting better rather than just focusing on performance goals, which is about proving the abilities you already have. The learning orientation fuels growth. It's about the journey of learning, getting smarter, not just the destination of looking smart. Okay, what about self-regulation and habits? Those seem key to making this stick.
they're absolutely key for sustained growth. The sources suggest building information consumption habits that keep you functional, maybe curating your news feed, scheduling learning time, and that remind you of useful concepts and your goals.
Staying focused.
And develop self-narration habits. This means consciously guiding your internal monologue on functional cognitive behavioral trajectories, perhaps reflecting constructively on your emotions, learning from past experiences, planning ahead.
Talking yourself through things effectively.
Basically, yes. Make useful goal setting a regular habit, breaking big goals down. And consider habit stacking, linking a new desired habit to an existing one to create effective rituals that reinforce learning and focus without relying solely on willpower.
Building systems for self-improvement. And bringing it all full circle now, how can the very AI, maybe even the future superintelligence we started with, actually turn into our partner, helping us cultivate our own abilities? The sources talked about amplification.
Right, that's where intelligence amplification, or IA, comes in, and the concept of human-centric AI. The idea is AI supporting, not replacing, human decision-making and cognition.
How would that work in practice?
Well, AI can offload cognitive labor, freeing up your mental bandwidth for higher-level thinking. Imagine AI helping you with problem representation, maybe visualizing complex data through knowledge graphs, making intricate issues easier to grasp,
Like a visual aid for thought?
or assisting with knowledge retrieval by suggesting relevant synonyms or related concepts when you're doing research, helping you find information you might have missed.
So it's like a super smart assistant that anticipates what you need to think better, anticipates your cognitive needs.
Exactly that. It could assist in formulating information needs, like suggesting more effective search queries, or help with data analysis by summarizing key findings, counting documents related to a topic, visualizing confidence scores and predictions.
Taking care of the grunt work of analysis.
A lot of it, potentially. It can even help you evaluate actions by suggesting relevant examples or counterarguments to consider. The levels of augmentation discussed range from simple assistive tools we already use, like calculators or spell checkers,
Right.
to supporting low-level cognition like pattern recognition, all the way up to high-level cognition like understanding complex concepts, and maybe even eventually reaching creative autonomy, where AI can synthesize novel human-inspired ideas, acting as a creative partner.
So it truly helps us work smarter, leveraging its strengths to boost ours.
That's the vision of human-centric AI and intelligence amplification, yes.
Wow. Okay, so we've journeyed from the incredible potential, maybe even the inevitability, of artificial superintelligence, built on scaled-up cognitive architectures and recursive self-improvement, all the way back to the rich, diverse, and surprisingly malleable landscape of human intelligence.
It's quite a spectrum.
We've seen that intelligence isn't a singular thing, definitely not just an IQ score, but this amazing collection of dynamic abilities: analytical, creative, practical, emotional, social, cultural. It's been a profound exploration, really highlighting how both machines and humans seem to be on this path of intellectual evolution.
It truly is fascinating. The future of intelligence is not just about the machines we build. It's very much also about understanding and cultivating the potential within ourselves.
So here's something to think about. If superintelligence will likely redefine what's possible for AI, what does that realization mean for your personal growth? How can you take inspiration from that potential for radical improvement, apply a growth mindset, and use some of these practical strategies we discussed? Whether it's learning that new language, diving into complex topics, practicing that critical thinking, or even just playing some strategy games? How can you use these ideas to amplify your own unique blend of intelligences and truly become your most capable self?
A great question to ponder.
The insights definitely don't stop here. Which aspect of intelligence, artificial or human, resonated most with you today? What's maybe one small step you'll take this week to cultivate your own incredible mind?